Okay, so an offsetting greenhouse truss has a span of 20 feet and 6 inches and pitches of 45 and 60 degrees. So remember to make your triangle offsetting. Your angles are 45 and 60, and you're solving for the height. Your 20 feet 6 inches, that's your span or little b. Convert that to inches, so 20 times 12 plus 6, that's your 246 inches. Um, Now you want to go to your formula package. So remember, you go to your formula package and then you go to the trigonometry section. And then in trigonometry, you've got solving for the heights. You're looking at condition one. Now, it didn't say condition one. So what you're looking for is the word truss. So whether it's just the word truss or offsetting truss, you're still using these formulas for condition one. So we're using this one because we're solving for height. So the B times tan A times tan C over tan A plus tan C. So I've rewritten it here. So you're just plugging in B is your span, 246, times tan 45, your pitch, and then your other pitch, tan 60, all divided by tan 45 plus tan 60. So just multiply the three together, 246 times tan 45 times tan 60. That equals 426.0845. And then separately, tan 45 plus tan 60. That equals 2.73205. Divide these two numbers, and there's your 155.9578 inches. Now, the question actually asks for feet inches. So take that and do your staircase method so that you convert it into feet inches. All right, number 8, calculate the area. So in inches squared. So it says inches squared. So I'm going to reuse my inches numbers. So um, my s- I had my height of 155, and then I had my span of 246. So area of a triangle, base times height divided by 2. So 246 multiplied with 155.9578 divided by 2, and that gives me my answer in inches squared. Now, number 9, convert to feet squared. So you're going to want to go back to your formula package again, and you're going to want to go to the conversion one. So go to conversions, and you're looking for the area section. So you're looking for inches squared to feet squared. So inches squared to feet squared is 144. You're going left, so you're going to divide by 144. So you're going to take that number, 19,182.809, divide that by 144, and that gives you your answer in feet squared. So 133.2 feet squared. Now, number 10. It says, if one sheet of plywood covers 32 feet squared, how many sheets are needed to cover the gable end? So I've done a picture here of gable end. This is a gable end. So it's at the end. So if you look at this, you've got trusses here. So there's a truss, and then this is a truss too. But because it's at the very end, it's your gable end. So here's a picture of this is considered a gable end because it's the very last truss. So that's what you're going to have to put plywood sheets on to finish it off so there's no gap. Also, a gable end is a specific way to frame it. So the inside is important too. So if you look at this, um, you can see that the truss you've got supports going vertically like this. And so that's a gable end as well, form of a truss. All right, so all we're doing is we're seeing how many sheets of plywood we got to buy. So we need to cover 133.2 feet squared. So all you got to do is do 133.2 and divide that by 32 because one sheet covers that many. So you're going to divide it by 32. I get an answer of 4.16. You got to be careful here. If you only buy 4 sheets of plywood, then you're going to have a little bit of a hole. So that's no good. So we always have to get extra. So therefore, you're going to need to buy, you need 5 full sheets of plywood. And so you'll just cut off the excess.